Today we're going to learn about recursion, which is one of the hardest topics in programming to fully grasp. On the bright side of life, it becomes more natural the more you do it. You won't use recursion all that often, but it is important to understand. One way to think of it is sort of like Diavolo's fate after fighting Gold Experience Requiem. Jojo Part 5 spoiler alert, so please jump to the bookmark to skip it if you don't want to be spoiled. Each time Diavolo dies, he starts in a new scenario until he dies, which then restarts the process. In Recursion, Diavolo's death is the call to that same kill Diavolo method that causes him to die, which at the end of the method calls back into itself to start a new loop of him dying. You kinda see my point, right? For those of you who avoided spoilers, think of it like a roguelike. You do some work, make some progress, eventually you die, /call the method you're currently in, and then you start over with slightly more experience or a slightly updated input. Recursion can be described as loop's bougie cousin. It has the same pitfalls of becoming an infinite loop, and almost any situation that can be solved with loops can be solved with recursion, and vice versa. Instead of performing a few lines of code, checking some condition for whether to continue, and then going through the code again, recursion works by using a method to call itself, which kinda sounds weird, right? Honestly, let's start with a while loop and then convert it, because that's going to be a lot easier just to understand. So let's do int I equals 10, while I greater than 0, system.out.println I minus minus, system.out.println. Run this, and you see we count down from 10 to 1, and then print boom. Now pull that into a method called countdown, and call it from our main method. And to be extra fun, let's give it a parameter that is the countdown timer, so it's more reusable. So private void countdown int I, and then our while loop system.out.println boom. Run it, and it works just as well as before. Now we will convert it to use recursion. Our first step will be to switch our while loop to an if statement, but with the same check. So just switch while for if. Now, after we decrement, we're going to call countdown I instead of looping through it again. Run this, and we see it countdown's the same as before, but now it prints boom a whole bunch of times instead of just once. This is an example of how recursion can do the same thing, but might be a bit trickier to implement. Instead, let's change our method a little bit more, and let's move our boom to the top, and rip that in an if statement. If I equals 0, system.out.println, boom. Now remove the other if check, but leave the code that was inside of it. Gah! Infinite loop! Kill it with fire! Or at least hit the stop button. Or what's more likely to happen is your computer will run out of memory and then just end the program itself, because each time a recursive call happens, it uses a little bit more of the computer's memory just temporarily to remember where it came from, until it eventually finishes. Now what went wrong? Well, every time the method called itself, it would eventually hit that countdown I call and then call itself again, even after it printed boom. It just kept going and going and going. How can we fix this? Well, we could wrap the logic below the if statement in the else statement, which would solve the bug, but that's not a best practice. What we actually want to do is go back into our if statement, and after our boom, we want to just write return, even though it's a void method. This is a nuance to Java. You can return from a void. It doesn't give anything back to the place you called the method, but it does immediately exit the method you're in. Now when we run it, everything works. This is the general flow of recursion. We hit some base case when we want to stop recursing down, so let's exit here after we do maybe one last thing or two. Think of it this way. Loops usually follow the pattern of check condition, if condition met, run code, recheck condition. Recursion does the same thing. Check some base case, if condition is met, do base case logic and return, otherwise do the regular logic, modify our input a little bit, and call the method again. It's definitely more complex, but there are times when managing things with loops would require a ton of tracking variables that are constantly changing, state might need to be managed as the loop progresses and eventually reverted, etc., whereas recursion will use local variables and passed-in values to manage a lot of that work under the hood, in exchange for being a little bit more complicated to understand. Truly an example of equivalent exchange. Just don't try to summon a person with it. It'll cost an arm and a leg. A great example of this I hope to cover in an upcoming series is the classic algorithm called depth first search. Can you do it with a loop? Yep. Is it quicker to write with recursion? Also, yep. Do you ever really need to do any of this after you interview? Not a chance. Note, some fields like maps and language stuff will probably require it, but a good chunk of stuff won't. And I'm going to stop the video here. I know it's confusing. I know you probably don't understand recursion all that well still. Don't beat yourself up if that's the case. You won't really need it until we get into the algorithms, and even then I'm still going to walk you through it step by step, and I think after that it'll start to be a little bit easier. And even after that, you still won't need it unless you're interviewing. I hope to see you in the next video. See you, Space Cowboy. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.